Hello and welcome to CEN 4801. After collecting system requirements and analyzing them, we can identify system performance specifications. This session will address system performance specifications in details. In general, specifications communicate the user's requirements to the manufacturer. They translate operational requirements into more technical language that tells the manufacturer one or first what we will consider an acceptable product, second how we will determine if the product is acceptable. A performance specification defines the functional requirements for the item, the environment in which it must operate, and interface. If the product exists, we can match the specifications and purchase the product off the shelf. But if it doesn't exist, then we have to relay that kind of information to the manufacturer. So if we use detailed specifications to tell the manufacturer this is how you need to make the product for us, that might be good and bad at the same time. Good that the product will meet our needs, exactly meets our needs. But bad if the manufacturer knows how to do a better job building the same product with more functionalities, less cost, more reliable or reliability, and we passed the opportunity by limiting them with what we provided as detailed specifications. So the problem becomes worse actually when we are not sure how to make the product we need, or we communicated our knowledge to the manufacturer poorly because we don't know anything about the product. At that point, we created a problem not only for the manufacturer but for us because we did not communicate the proper specifications or requirements for the manufacturer. That's why we need what we call performance specifications. The performance specifications leave out unnecessary how-to or details about the product and give the manufacturer the latitude to determine how to best meet our stated needs. All what you say, this is what I needed to perform, this is what I needed to do, and you leave it to the manufacturer to figure out how to do that. In order to write an effective performance requirements, we must understand and identify involved entities and the relationships for various types of specifications. Although we define the entities and their relationships, we define um, performance specifications through stating requirements in terms of the required results with criteria for verifying compliance. We state what we need from each one, and we state how are we going to measure or verify that it does or comply with what we need. We're not stating the details on how to do that, just specifying a product that can do this and that should be verified that it can do what was required to do. The system performance specifications will be translated into item development specifications that could be for a product or subsystem or anything similar. The item development specifications will be supported by item design or fabrication specifications, item process specifications, item material specifications, and item facility specifications, which will be translated, all that will be translated into item procurement or development process to produce the item uh, based on the product specifications. So now with all these being known, that will be translated into the item or product specifications. The performance-based approach specifies system or entity capability requirements in terms of performance boundary conditions and transactions. The system or entity we might be treated as simple as a box. We can treat it as simple as a box with inputs and outputs as shown in this figure. The performance specifications represents the preferred approach to specification development for many applications, particularly exceptional systems. An example of performance requirements, for example, we have the detector that shall not contain foreign matter such as dust, dirt, fingerprints, or moisture that can be detected by visual examination. The reason for that it should provide criteria. We should provide criteria for compliance, which is assuming that foreign matter affects detector performance. So what we did, we provided the um, requirements or the results that what I need um, this item to perform at the end, and then we said, okay, I don't need this foreign matter to be there, or I don't need this dust, dirt, or fingerprints to be there because that will affect the detector performance, and I will provide certain criteria to verify that. An example of unnecessary details that could be given to the manufacturer is going very specific. For example, the cloth shall be made from cotton that has been uh, uh, carded and spun into single yarn for both the wrap and filling. The weave shall be 5 harness satin. The filling effect side shall be finished and identified as the face side. That's too much details. And with having those details now, this tells the manufacturer how to make the cloth. We are telling them how to make the cloth for us, not what type and quality of cloth the user desires. So you can see from the example or from the examples giving that providing design details might limit manufacturer innovation and creativity. Yeah, they're going to provide you with what you need or what you requested, but you're limiting them with creativity. They're not adding anything. They might not even look at the cost. They want to provide you with this item that you asked for because you gave them detailed design specifications. So let's avoid that and concentrate on giving the manufacturer the performance. What do you need this item to perform or to do at the end of utilizing it in a system or within a system? Or what do you need the whole system to do? What's the goal of the system? And what's the role of that entity within that system? Using performance-based development and avoiding design-specific requirements will provide system developers with flexibility to innovate and create any number of architectural solutions within contracts, cost, schedule, and risk constraints. So you put for them boundaries. You put for them the cost. This is what the budget that you will be given. I need it within this period of time. That's the schedule. And then those are the risk and constraints or limitation within or boundaries that you need to work within. The performance-based specifications require extensive system developer or subcontractor structured analysis and derivation of requirements to select a preferred system architecture. They're not going to leave it as it was given. They will do the required analysis to find the proper requirement that will end up performing as needed. The system owners favor the preference-based specifications approach, and we know why, as the initial step of multi-phase acquisition strategy where requirements may be unknown or immature. When they don't know anything about the product, they don't know anything about the design details, yeah, it's better for the owner to just provide performance based specification, and this is what I needed to perform, and the developer will take care of developing an item or finding an item that can perform as required. The strategy may employ a series of spiral development contracts to evolve and mature the system requirements, and this is one of the methods that's been used in product or system development life cycle, and you go with iterations until you find the proper system or proper entity that will provide you with the performance needed. So what's the importance of the system development phase? The primary objective of the system development phase is to translate the contract and system performance specifications uh, requirements into a physical deliverable system that has been verified against those requirements and validated by the user if required. And of course, it should be formally accepted by the user or the acquirer as the user's contract and technical representative. Each solution space is bounded by requirements specific in its SPS. So if there are any errors in tactical or engineering judgment, they are magnified in the requirements document in the SPS, the system performance specification document. So the challenge question for the acquirer or the user, and ultimately for the system developer, is how or have we specified the right system solution space to satisfy one or more operational needs problem space. And this is a very important question to answer. So if we can answer this, if we don't have any errors, then we should be able to find the proper item that can do that, or build or develop the proper item that can do that. Now, the SPS requirements should be subjected to requirements validation against the operational need to validate that the right solution space description has been accurately and precisely bounded by the system performance specification document. So we did the verification, we did the validation, and now we're ready to use the system. Once the SPS requirements have been validated, the SPS document will serve as organizing or originating or source requirements inputs to system design. This is what we are going to do, or we are going to use once it's verified for the system design and development process or phase. During the system design, temporary design verification is performed on the evolving system design solution by tracing allocated requirements back to the SPS document and prototyping design areas for risk mitigation and critical operational or technical issue resolution. Design validation activities should also be performed to confirm that the user and system owner agree that the evolving system design solution satisfies their needs. So we're still validating until the last minute, until we start the design activities and go within the design activities. And as we stated before, we have a spiral approach where we go with a different iteration, going back and forth with the owner, with the user, to make sure that the evolved system or the system that will be delivered at the end satisfies their needs. That will be all for this session. If you have any questions, you can email it to me, or you can come in person during office hours. Thank you and have a great day.